ולהתחיל. יופי. אז אחר הצהריים טובים, נראה לי שככה קוראים לזה, שעה 4, מפגש נוסף של הדאטה פלטפורם Meetup, ונעבור לדברים הרגילים. תמיד יש ככה אנשים חדשים, לא תמיד כולם מכירים בזה, אז חשוב לי כן לעבור לדברים שתכירו מה קיים, מה יש, בעיקר אירועים קרובים, כי יש המון אירועים, אז נעבור קצת עליהם. אז קודם כל אנחנו באתר Meetup, דאטה פלטפורם Meetup, יש פה את הלינקים ואת הברקודים למי שרוצה לסרוק. אם יש פה מישהו שעדיין לא רשום, תירשמו כדי לקבל עדכונים ולהצטרף לאירועים שלנו. רגע, רונן עושה ככה, מה זה אומר? זה שאלה? הערה? או שזה בטעות נתקרא לך יד למעלה? לא? Sorry, we have some English-speaking attendees in the audience. I know that Dan is also going to do the presentation in English. So I will switch to English. I hope it's okay with you. So we're doing it in English. Let me talk about the Data Platform Meetup, a few things, announcements and updates about upcoming meetings, and then we'll move to the presentation. So we are in the Meetup website, Data Platform Meetup. You can use the links and the barcodes here to register. We are also on Facebook. Most of the things there are in Hebrew, but you are welcome to join. There are many discussions about professional stuff, people that are looking for jobs, stuff like that. We also have the Global Hebrew virtual group. We are part of PAS, a global organization for all the Microsoft Data Platform professionals out there. So we are a local group. We are the Israeli local group of PAS, and we also have the virtual group, Global Hebrew, which Ronen Arieli is leading. And we also have some webinars there once in a while. I'll talk about one of them in the upcoming events. We have the YouTube channels. Most of the sessions are recorded. We record like this one, and then we upload the sessions to our YouTube channel, so you can subscribe there and get notifications about new session recordings or view past recordings in the archive. And we also have SQL Server Radio. This is a podcast that myself and Eitan Blumin, we co-host together. We talk about everything related to SQL Server, events in the community, some professional stuff, our own experiences. Sometimes we have guests that we interview, new features and releases, and so on and so on. Everything about SQL Server. We release a show once every month. We have one in Hebrew. This link leads to the Hebrew show. We also have one in English. Instead of CYL, just replace it with .com at the end of the URL there, and we will get to the English edition. As I mentioned earlier, we are part of PAS. If you're not registered already, I suggest that you register to PAS, become a member of PAS, and you can benefit from all kinds of free resources, learning resources like webinars, blog posts, articles, and so on. So feel free to subscribe. The biggest event of PAS once a year is PAS Summit, and this year it's going to take place in November, and it's going to be virtual. This is the first time PAS Summit is virtual, like every other conference in the world these days. And this means that you don't have to buy an expensive ticket. You still need to purchase a ticket, but it's a lot cheaper than usual. And also you don't need to fly, pay for a hotel and so on. So it's a lot more affordable than ever. And I recommend that you register to PAS Summit. Go check. They have just released the sessions, the schedule of the sessions. Well, not the schedule, but the sessions, chosen sessions, the speakers. So you can see the lineup, what is there to expect. There are lots of great sessions. I'm honored to be one of the speakers. I was chosen to give a session in PAS Summit about data platform modernization, how to modernize your data platform. Check it out, register. I really recommend to do so. It's a great opportunity because usually people can't afford the flight tickets and hotel and so on and so on. So it's a great opportunity. And if you do register to PAS Summit, use this discount code. You get a $50 discount during registration. So write it down and use this code here, VGDISK32A. All right, next. If there's anyone here who is looking for a job these days, or if there is anyone here representing an organization, a business that is looking for data professionals, feel free to talk to me or post in the Facebook group. Talk about yourself, about the position that is open, because part of the role of this community is to help each other in such cases. And let's talk about events. So the previous meetup, which we had, I think it was last week. Yes, last week. Yossi Drori talked about data integration in ETLs. Again, you can go to the Meetup page. You can use this link here or the barcode, and you will find there in the comments section, you will find the links to download the session materials and also a link to the YouTube, the session recording itself. So this was last week. And what can we expect in the upcoming future? So today, right after this one, today at 6 p.m., there is a session by Century One together with, oh my God, I forgot his name, sorry, Italian guy, talking about workload tools. It's an open source project for benchmarking. If you need to benchmark SQL Server environment before and after a change that you are doing, like upgrading SQL Server or doing something with the code or whatever. It's a nice solution for benchmarking. Check it out. Interesting stuff. This is today. Next, tomorrow evening, Israel time, starting at 9 p.m., there is a PAS marathon about SQL Server performance. Really interesting. 7 back-to-back sessions. It starts at 9 p.m., ends at 4 a.m. on Friday morning. Great sessions. Check it out. Register. It's free. You can choose, of course, which sessions you want to attend. And I also believe that everything will be recorded, so you can also access it afterwards. What else? I talked about the Global Hebrew. So on August 2nd, we have a session as part of the Global Hebrew about that data univariate. I'm not sure how to pronounce it, forecast engine. Not sure about the content, but you can check it out. Again, follow the link and barcode to see what it's all about. On August 4, as part of what we do in Madeira Data Solutions, we have a live webinar once a month, every Tuesday, the first Tuesday of the month at 11 a.m. This time it's my turn. I'm going to speak about how to use parameters in SQL Server to boost performance. It's a very famous session. I've done it many times, but I always see new faces and people tell me that they learn something new, so I will keep on doing it. A very important topic in SQL Server for performance. So this is going to be on August 4th. And on the same day, at 5 p.m., we have another session of the Data Platform Meetup. This time, Ami Levin will do a session about database design, 7 deadly sins of database design. A very interesting session. We have a lot to expect. And the next one on August 9 is the future of analytics with Azure Synapse Analytics by Yossi El-Kayam from Microsoft. Another very interesting session. And there are a lot more coming up, but I think that's the last one. Yeah, I'm not going to talk about everything that we have planned. You can go to the Meetup page of our Meetup and see all the future sessions. We keep adding more and more all the time, so there's a lot to expect. Today, Dan Weitzner, I hope I pronounced it right, from timbr is going to talk about SQL Knowledge Graph, and I will let Dan explain all about it. If you have any questions during the session, feel free to write them in the chat. There are some people here I know from Dan's team that would be happy to answer you in the chat, and we will also have time after the session for Q&A if you have anything else to ask. So Dan, up to you. Take the lead.
Thank you very much, Guy. Allow me to share my screen. See, okay. This one, that's right. All right. So hello, everybody. Welcome. I hope everyone is excited as I am. I'm glad to be presenting timbr AI to fellow data consumers. And let me start a little bit with introducing myself. My name is Dan Weitzner. I'm a VP R&D and co-founder of timbr AI. I've been a programmer, developer, coder for most of my professional career. And in my personal life, I've also been a printer repairman, a remote TV operator, and anything slightly tech-related that requires a minimum amount of reading instructions or documentation. I like science, philosophy, and I'm also an enthusiast regarding knowledge bases and knowledge representation. In timbr AI, we bridge the gap between data and knowledge, and we bring it into the standard SQL world. In this presentation, I'm going to present our solution to the gap, give a short demo about the capabilities that timbr brings to the table, and I will try to make it as quick enough to allow more time for the Q&A part. Okay, so let's start. The gap between data and knowledge is actually the gap of how machines or computers think and how we as humans think. Like we all know, most machines that have a database are probably running a relational database. So machines view the world in terms of logical relational database operations. However, us as humans, we view the world in terms of ontologies, knowledge representation. We see the world in concepts and relationships. Our minds automatically make distinctions and observations between abstract and material concepts as we conceive them in the real world. As database moderators, we have all suffered from this gap. We're often required to think the human way of thinking and translate it to think in terms of tables and columns to answer a specific query. This gap in the way of thinking is so common that it can be easily expressed in a tweet, like I saw a couple of months ago, 20th of April. Then, can you just quickly pull this data for me? And me, sure, let me just select star from some ideal and clean and pristine table that you think that exists. So this is something that I'm sure many of us experienced in the past. So the gap between relational databases and human thought. Relational database rely on relational algebra, whereas the human mind thinks in terms of abstract concepts and relationships and what they represent. Relational databases have a flat view of the world, where any table is a private autonomous entity, whereas the human worldview is multidimensional, connected, and ambiguous. Relational databases have no inference rules out of the box, whereas human thinking intuitively reason over ontology and semantics. In relational databases, everything is an observation that is explicitly defined in the query, whereas the human query explicitly and implicitly, and everything can be an abstraction or observation. There are many solutions in the market that solve this gap, but most of them suffer from limitations and different barriers of adoption. So the market saw the need for bridging the gap, and a lot of new solutions, companies, and databases came to light to help with the effort to bridge that gap. But then some new problems came into light, which require significant efforts for implementing and maintaining the knowledge graph. Some require adding additional infrastructure to support the knowledge graph and the systems. Some require loading and transforming the database for its initial setup, maybe an ongoing ETL process to ensure new data is always coming into the knowledge. Maybe many knowledge graphs have limited scalability when they need to scale north from 5 terabytes. Some require learning a new language to query the data and model the knowledge graph. This usually comes with a steep learning curve. And some do not connect to almost every one of them don't connect to business intelligence solutions. So non-savvy data consumers can't enjoy the power of the knowledge graph. Last but not least, the big data elephant in the room is growing as time goes by. So what about big data? The more data you have, the more problems you're likely to experience. Whether you have to make sense of thousands of hundreds of tables and views, maybe you need to combine different relationships to allow transitivity in your queries, and there are many different types of relationships that you can make. Not all columns will be annotated with an explanation. For example, a column of width can be expressed in one table as an integer representing pixels, and in another table it can be a float representing centimeters for a product. The more logic operations you need to follow and apply in an SQL query, the harder it is to share, scale, and reuse the knowledge across the organization. So we took all these challenges in consideration when we created the timbr AI. So timbr AI. We're trying to remove those barriers of adoption. Our solution is a virtual layer on top of existing database. You don't need to add a new database to your system and managing and synchronizing between those two databases. So there's no need for any ETL. extract, transform, or load operations to load the new database since it's virtual. It operates in standard SQL, so you can always query it in SQL. And since it's operating in standard SQL, there's seamless integration with BI tools because all BI tools speak SQL. And it's made for big data, so you connect them to your data lakes and data warehouses, wherever they may be. So in a high level, the difference between using a relational database with timbr and using a relational database without timbr can be summed up with the following. Without timbr, you're left with the immense power of relational algebra and all the joy and productivity it has brought into our lives. With timbr, you keep the immense power of relational algebra and add inference rules to gain another level of capabilities and expressivity that is closer to how humans perceive the world. Let's dive into the differences in these two perspectives. So everything in timbr is based on what's there in the relational database. Therefore, in some sense, everything corresponds quite nicely one to another and behaves similarly. But there are some distinctions. Ontology in timbr, in addition of being a catalog, it has other settings and configurations that correspond specifically to the ontological aspect of the catalog. For example, how many jumps as graph traversals would you like to see in the metadata of a concept? In addition to all the schemas for a given catalog, timbr provides an additional 3 different schemas to view the ontology, 3 different perspectives from which you can view a certain table or concept. I will drill down in following slides a bit more about this. Concept is a table or view, but it has inference and inheritance properties due to the hierarchical nature of the ontology, and more powers, which will also be discussed later on. And a column is a property, but instead of the column being constrained by the table where it was created, a property must be consistent across the whole ontology catalog. A column can also be a relationship where the column is constrained as a foreign key to another table. Relationships, like properties, must also be consistent throughout the whole ontology. So why do we need these distinctions and how these distinctions help us? When we look at the metadata in any relational database, we can see a flat world of tables where we can find some relationships between the tables as constraints between foreign keys. But not always we have foreign keys, and overall each table is its own private entity. When we look at the ontological view of the data, we get a multidimensional view of the world where there is an abstract hierarchy with governing rules between the concepts, between the tables. Every concept or table and every property or column is accounted and can provide context when you query it. Let's take a closer look. If we look at these two tables, in our mind, we can almost immediately understand each row represents a person. But from the table view, it is absolutely agnostic with its relationship to other tables unless it was explicitly defined when creating or altering the table. Because of this autonomous nature of each table, each column also lives in a confined environment of the table in which it was defined. What's more, we can consider ourselves lucky if the column is annotated with a description of its content. Some of these questions might come to mind when thinking about these tables. Let's see how timbr for example, does height needs to be the same data type across tables? Maybe. Do full name and lead name represent the same thing? Seems so. Is weight represented in the same unit of measurement thing across tables? I'm not sure. This can be in centimeters, this can be in inches, or and about the tables themselves. What is the relationship between the two tables, leads and customers? What is conceptually mutual to both tables? We can say they both have an ID, they both have a name, which full name or lead name, height and weight seem to be conceptually mutual. Okay, so in other words, we have the same tables, but we will create an abstraction based on our knowledge. That's what we used to do when we were presented a business question from a consumer. He expects the data to be represented something like this. You have the customers table, can be mapped to like a concept of a customer, have a lead which is mapped to the table of the leads, and both of them inherit from person. After we map from the tables customers and leads to their respective abstract concepts, for customers, we can map the column full name. From customers, we can map the full name as a name, a person name. And from the leads, we can map lead name also as a person name, since they represent the same thing. When we query customer, we will get all the data from the table with the properties that we define in customer. When we query lead, we'll also get all the data from the table with the properties we defined in lead. But when we query person, we will get a unified vision, union all of the customers and leads, since they're both persons. Another example, let's look at the following query. Pretty straightforward and easy to understand, right? Select title, name, location from some table, limit 3. Okay, let's look at the results. Okay, we got title, we got a name, and we have a location. But can we understand the relationship between title, name, and location just by looking at the results? No. Some tables allow adding annotations and description to columns in the database, then expose them as part of the metadata. But from only looking at the query of the results, can we conclude the semantics of our query? Is this person the creator of the title? Is he the artist? Is he the rights holder? Is the Dallas Museum of Art the location of the title? Is the location of the person? Maybe it's another location of something else represented in the data. How can you determine the semantics of the query, So it all begins by bringing order to the chaos with the power of ontologies. What does the queen refer to? If you get the sentence, can you spot the queen? What does the queen refer to? What is the context provided? A queen can be a person. It can be the name of the person, like Queen Latifah, or it can be the status of a person, like the Queen of England. A queen can be the bee queen or the ant queen. It can be an animal. A queen can be the band queen. It may be a game. Maybe you're referring to a queen in a game. It can be a queen in chess or a queen in a cards game. Queen can represent many different things. So the semantics, to answer this, once we have a defined ontology with rules, we can choose the proper context that relates to the question. So depending on our data and how we model our ontology, for example, we can provide context to this question we asked, for example, what is the role of the queen in different games? In this case, if we query the concept of game, we will get the results of all the data points that are related to a game, to a queen in a game. But we'll also get data points of the child concepts. Other questions can be, what is the total amount of albums, all bands with the word queen in them? What animals have the role of, what are the names of all the queens in the royal family? Which person have the word queen in their name? All of these can be connected to different entities in our ontology. So by following reasonable steps, you get the logical consequence. A queen can be checkers, which is a game, which is a thing. A queen can be a brand, which is a thing. A queen can be a person, which is an animal. Everything in the end can be a thing. So how does a knowledge graph translate to SQL? Thing has something to do with thing. Since the requirements are a little bit unclear, we took a more generic approach. And in some sense, this is always right, but it doesn't help us very much. Okay. So how we do it in timbr? In timbr, what you have in this example, you have 1, 2, 3, 4 tables. A table of a person with a name, age, and birthplace, a table of a city with a name, population, and a located to country with a foreign key to countries, country, name, population located in continent, and continent, name, population, and number of countries. We can see the linear connection between the tables. In timbr, or any person can see that cities, countries, and continents correspond to a place, and a place has name and population. So city, country, continent will receive the properties from place, and each and every one of them can retain their own direct properties that are defined in the space table or concept. So a person can have a relationship to place, like birthplace, and we can jump from different type of table using this ontological relationship that we create. So another example, if I have a table of Google campaigns, if I look at it from the schema of timbr, I suddenly see that city is related to another concept that has GDP, population. Maybe city is related to another concept, which is called weather, and then I can get the properties of weather as average temperature, and then I do 3 jumps in the graph from a Google campaign to a city, from a city to a weather, and from the weather I get the average temp. And all this is exposed to me as more columns in the metadata. So a little bit about the class inheritance, the concept inheritance that I explained earlier. If I have a concept of a campaign, and a campaign has ID, impression, clicks, conversions, and date, and then I create another concept that inherits from campaign, call it Google campaign, it will get all the properties from the parent, and it may have its own distinct direct properties related to it. Same for Facebook campaign. Facebook campaign may also have these columns that are related to a campaign, but it may also have its distinct columns in the data, which will be translated to distinct properties like age viewer or view time. Okay, so we have 3 different schemas for each concept in our ontology, in our knowledge graph. The first is the intrinsic schema. In the intrinsic schema, if we look at the campaign concept, we get all the direct properties that correspond to the campaign concept. In the exhaustive schema, we get all the direct properties of campaign plus all the properties of the children of campaign. Like, for example, what you had in Google campaign and what you had in Facebook campaign. In the normalized or the reference table, we have a concept, we have all the direct properties, and also we can see many graph traversals that you can perform from a single concept. So how did we do it? Where is this idea? We didn't invent it. We took it from philosophy and from the semantic web. We've simply implemented OWL and RDFS specifications in SQL. We've extended the SQL standard with ontological support. And by doing so, we've implemented an SQL reasoner, which can also support existing OWL ontologies. We want to bridge the gap, not replace OWL and RDFS specifications. Let's see some comparison in SPARQL. In SPARQL, you would do a question like this to get all the CEOs of US companies born outside in US. In timbr, you would simply do it like this. Name, CEO, CEO.birthplace.country will bring me the country in the birthplace, and you'll get where the CEO birthplace country label is not the United States of America. In Cypher, the language in Neo4j, we get another query. This is for a fraud detection example, where you also can do graph queries. And since timbr is a virtual layer, integration is seamless between the underlying data structures and the BI and analytics and data querying solutions that is available to be queried and modified by any machine learning framework that supports JDBC or ODBC. Most importantly, companies can use timbr concept modeling rules to manage, share, and preserve organizational knowledge and take advantage of its reasoning capabilities to facilitate the implementation of artificial intelligence initiatives. Okay, so let's go to the demo. Okay, can you see my screen? I hope my screen is visible. Yes, was it? Guy? I can't hear you.
I was muted, sorry. We see the PowerPoint, not the demo.
Oh, let me share the screen again, one moment. Okay, what about now?
Yeah, now we can see it.
Okay, excellent. So it's a little spoiler. So what do we see? We're connected to a Google BigQuery right now. We got a public data set of traffic. It gives us traffic accidents from 2015, 2016. We can see that the tables are partitioned. And when we look at the metadata, we can't really know the relationships between all those different tables. I mean, there's a person, there's a park work. I can enter a certain table and see what's going on there, but I don't really see what are the connections between them, or is there any hierarchy that by using timbr, I can create any hierarchy that I want as I see fit in my business needs, whatever they are. And I can say, for example, every node on the screen is a concept. You can see that every concept inherits from thing. When I click on a concept, I get the description of the concept, which hierarchy level it sits, how many properties it has, how many relationships, what are the direct properties or inherited, and what relationships do I have. So if I look at accident contributors, I see I have two direct relationships from accident to accident and from vehicle to vehicle info. And I can see that I have three direct properties. When I go to vision obstruction, for example, which inherits from accident contributor, I get also the description. But when I go to the properties, I can see that it inherits the three properties from accident contributor. And it also has two direct properties. Same for the relationships. It has two inherited relationships it gets from accident contributors. And the same goes for accident car contributors here. On the left side, I can also see like a tree view representation of the graph. So it's easier to, some people find it easier to find things, or I can filter the graph by double clicking a concept or finding it or searching for it here. I can, once I filter or without filtering, I can right click on any concept, say show relationships, and then I get different relationships to other concepts. I know that accident contributor relates to accident through accident, and accident contributor relates to the vehicle info concept through vehicle. And I can go forward from accident and show more relationship to more concepts if I want. Now, let's see a little bit about how it looks in the queries. So if I look at the queries, we can find here, so these three queries. Okay, so let's see all the accident contributors that we have. I run this query, and then I can see the different type of concepts that this query represented. I query from the accident contributors, and I see that some of them get the vision obstruction and others get the accident car contributors directly, and I get the different results for it. I can also see what timbr did behind the scenes. So we get a very large query that behind the scenes does the different unions that we need for this query. Similarly, for another query, in this one, we go to, through the accident relationship, we get the name of the state. So this one involves the graph traversal. When I run it, I get also the state name that an accident contributor relates to. And I can also explain the query and see here that it does the left join with where I needed to be to get the answers that I need. If I go back to the ontology, here, go back to the ontology. And I suddenly decide that driver distraction is also an accident contributor, then I can easily edit this concept of driver distraction, and instead of inheriting from thing, I want it to inherit from accident contributors. Just by doing that, the inherited properties get updated automatically. I click save. This is what I really want. And now accident contributors have 3 children. One of them is driver.
Excuse me.
Now, if I go back to the queries and I don't change the query stays the same, I suddenly get I suddenly get also the driving distraction that we wanted. Driver distraction, for example. So the query doesn't change, although that I change the ontology. Everything is virtual, and all the queries can stay the same. The data gets updated on the fly. Let's go back to the, oh, sorry. Get back to the example. It was here, okay. Yes. Another thing we can do, if we want, we can, for example, visualize this as a graph or as a chart. We can change the mappings directly, or we can fetch the sample data to see what specific, to get 50 rows just to see what the data is like. And we can visualize this as a graph, explore it as a graph. Okay. So this is just one way. I will get into it in a minute. Or you know what? Okay, let's do it. Let's do it from the accident. Explore as a graph. Yes. Okay, so now I have 10 data points from the data exploration. This is not enough. Let's add some more. So I want accidents, and I want, let's say, about 94 is okay. Let's add the 94 data points. So now we have 94 data points, and I don't like that they don't have a label. Let's change the label for the accidents. So I can go and see by the properties that these have. Let's say land use name I can take any different, like road signing name, maybe the state name. Let's try by the state name. So we change the group settings. I want to see it by the state name. And suddenly I can see that most of my data points came from Iowa. This is fine. Maybe route signing name. Okay, better. Now from accident, I can go and ask, okay, I want to see the vehicle information, for example, that relates to each one of these data points. And I want all the properties with the limit to my query to, let's say, another 95. So now when I ask for the targets, I get suddenly the vehicle information of this of this concept. Now every action that you do is recorded here in the action log. I see that the colors are a bit too similar, so I can go on and change the color or the background, for example, and the border, also the label. And now if I want, for example, to group them by a specific property, I can ask, okay, let's group them maybe by the vehicle make. So it's up here, vehicle model. Yes. And now you get a nice graph where you can come and say, okay, this group interests me. Let's isolate it from the rest of the graph. And you can keep exploring and playing with your data in a graphical manner. This is our data exploration. It's still in beta. Okay. And something else that we can do, for example, if we want to see the accident as a chart, we got a BI tool that is implemented. Our solution is based on the Apache superset. We contribute to Apache superset. It's an open source project donated from Airbnb to Apache Software Foundation. Okay, so now that I asked to get a chart, for example, for the accidents, I can say, okay, I want to see a visualization of a nightline rows, for example. But now I see that I don't have any time columns. So I can create a calculated column. I can see that hour is a temporal type of column. I'm going to save it, sorry. Now I need to ask for a metric. I'll just do a count that the chart requires. And of course, choose the time column that I need. And now that I have this nice chart, I can see that some formatting is wrong here. So I can change it in the visual properties. Since it was adaptive, it tried to figure out alone what 00 means. Let's help it. Okay. So now I get all the accidents distributed by time. I can go on and say, okay, let's try to group them maybe by state name, for example. And then you have another nice breakdown of how it breaks per hour per state. I can choose to keep, for example, Illinois, Indiana, and Iowa, and Kansas. And I can drill down to a specific hour to see how it's written. And this is an example for. This is more or less it, the time for our presentation. Thank you very much for seeing it, and we're ready to answer any questions.
Thank you, Dan. If anyone has any questions, I guess you can open your mic and ask. It could be English or Hebrew. It's also okay. Feel free. אם יש שאלות למישהו בעברית זה גם הולך. אתה רואה את הצ'אט?
אני רואה את הצ'אט, כן.
אז בוא, יש פה כמה שאלות אולי, במקום שאני אקריא אותם, יהיה לי יותר קל שאתה פשוט תסתכל עליהם עצמך.
אוקיי. So אני פשוט עולה למעלה, אני מסתכל, הרבה דברים קרו מאז שהתחלנו. אני יודע, כן. Does Timbr support RDF databases for graph visualizations? Yes. How does Timbr display cardinal relationships between entities? And 3, does Timbr support shackle constraints? Well, it's in SQL, so it's not shackle, but it's the same type of constraints that are applied in shackle. Shackle, you use it to make constraints in OWL and RDF. We use SQL to do it. השם הגרוע. Oh, okay. I see that people answered Abhishek. Okay, it's great. Okay, my brain just exploded. I've seen those behind the scenes queries. Yes, that's right, Eitan. There are a lot of crazy queries going behind the scenes. Can make books out of the translated queries that we produce. Sorry, but I can't see your screen. Steven, try extension again. האם הצמתים מחוברים, למה הכוונה? Performance benchmark, how timbr performs for complex query versus SPARQL. Okay, so that's a great question about the performance benchmark. We push the queries down to your data sources. So if you're using, for example, in what I showed, I used the Google BigQuery. So Google BigQuery has its own benchmarking and performances and optimizations done to the database itself. We enjoy the same type of optimizations. We do optimizations to the query itself, but the backend is the one that gives performance. So you can scale accordingly depending on your cloud, depending on what the data source is. Timbr also supports approval workflows. I'm not sure what the approval workflows is, I'm sorry, but maybe someone from our team can help you.
Sorry, can I quickly check? The question regarding approval workflows was in terms of if the ontology has been maintained and if the changes that occurs to it, how is the change process controlled or governed across, is there some kind of governance mechanism associated with it?
Well, it can be. A user can be an ontology curator or not. You can also create the concepts and create the mappings and all that fun stuff directly through SQL DDL. So if you want your, in your machine learning pipeline, you want to create concepts and query them or do some sort of abstractions or distinctions or classifications, you can easily do it from SQL DDL as well. You don't have to use our platform to do it. There is no problem changing ontologies. We have in the pipeline managing ontologies, you have the data versions like in Git, for example, or any repository management system where you can go back and forth for the states of the different states of the ontology. I hope this answers the question.
Yeah, thanks for that. Regarding the benchmark, I was just curious to know if there is some test that has already been done again, Virtuoso, AWS Neptune, Neo4j, and likes of that, if possible, to put some ballpark numbers, if possible, of how Timbr has performed.
Well, we checked Timbr with regards to different cloud providers. We didn't check in. When we checked different knowledge graphs against Timbr, we just wanted to check that we return the same results and the logic is the same. We didn't benchmark for performance because our performance depends on the backend of the user. So if you have like a very big, large SQL server running behind the scenes, then you'll have that performance. But if you have some small database with not much memory in it, then that's the performance that you're going to get.
Yep.
Since we are virtual and we don't do any compilation ourselves, just the query, we don't. Our performance is dependent on the backend. That's what I'm trying to say.
Okay. Thanks, Dan. Thanks for your time. I really liked your presentation on EDM Council as well.
Oh, thank you very much. Thank you. Appreciate it.
אוקיי. עוד שאלות? מישהו? מעולה. So thank you, Dan. תודה רבה. חבר'ה, אנחנו נפגשים שוב במפגש הבא של המיטאפ ב4 לאוגוסט. מזכיר לכם, יש עוד הרבה דברים עד אז, אבל ב4 לאוגוסט זה המפגש הבא שלנו, של עמי לוין. כנסו לאתר, תירשמו, נתראה. תודה רבה. יאללה ביי.
תודה. Thank you very much everyone for attending and listening. תודה, Guy. Thank you very much for inviting me.